Welcome. Today we're going to learn about function notation, and after we learn function notation, evaluating them or how to evaluate them. Now, functions, for the most part, we're going to relate two numbers, x's and y's. So a lot of times functions can be written as like y. Here's a very simple function, y equals 3x plus 5. That's a linear function. Okay, now function notation, though, we write this a little bit differently. In function notation, we don't use a y for output. What we do is we're going to replace the y with the not capital, but kind of a cursive letter F. And next to it, we're going to put a parentheses with the what we call the variable or independent variable that we're going to evaluate. And so and it's pronounced f of x. F of x is equal to 3x plus 5. These are exactly the same equation. Y equals 3x plus 5, and f of x, that's again how it's pronounced, f of x equals 3x plus 5, mean exactly the same thing. They're the same equations. So before, I would say, okay, if x is 2, what is y? So I actually have to put, if x equals 2, I'd put that here. X equals 2, and then ask you what's y. You'd come over here, you'd plug a 2 here, replace the x with the 2. 2 times 3 is 6. 6 plus 5 is 11. You'd say y is 11. In function notation, we don't say x equals 2. What we would do is we say, what is the function, or evaluate the function, or what is f of 2? That actually means exactly the same thing as if I ask you, what is y when x equals 2? So what we do now is we just look over here at this expression and say, oh, I replaced the x with a 2, so I'm going to replace this x with a 2. What's 3 times 2? Well, it's 6. 6 plus 5 is 11. So f of 2 is 11. It means exactly the same thing. So if you think about it, we have a point 2, 11, right? First number is x, second number is y, 2, 11, 2, 11. First number is x, second number is y, 2, 11. So again, inside the little parentheses is our x value. This whole expression is the outcome, or it's equal to 11. Okay, now I want to emphasize, though, that in function notation, you don't always have to use this cursive f. For instance, they might give you something like this function, a capital G or a cursive G of x. It's still function notation. G of x equals 4 minus x divided by 47. Okay, and then what they'll do is they'll say, okay, if g of x equals 4 minus x divided by 47, what is g of 47? Again, very simple. Not a difficult thing to process, because what we want to do is we want to replace this x with a 47. So again, I could rewrite this whole expression as 4 now minus 47 divided by 47. Well, that's 4 minus 1, or 3. So g of 47 is equal to 3. Or it's the point 47, 3. Or x equals 47, y equals 3. So don't let the function notation confuse you. Here's another one they might give you. They might give you h of x. Again, this should be kind of a cursive looking, but an h of x equals 10 times the absolute value of negative 10 minus x. Now, I want to introduce again, if you don't remember, these two straight up and down line bars mean absolute value. And then they might ask you to find something like, what's h of 11? Well, again, h of 11 is going to be 10 times the absolute value of negative 10 minus, what did we say x was? X was 11. And then the absolute value bar. Just like parentheses, I'm going to combine inside first. So I'm going to say, all right, I have 10 times the absolute value of what's negative 10 minus 11 more? Negative 21, right? And now what's the absolute value of negative 21? The absolute value of negative 21 is 21. And what's 10 times 21? 210. So h of 11 is 210. Now, I believe in your homework, you're not going to ever see H function or a G function. You could see a K, an L function. I believe they do them all as Fs. So when you go to do your homework, you might see this function, f of x, because I believe they always use this kind of cursive f, equals, and your functions are going to be a little bit harder than just linear. You might get one like this, f of x, again, that's how it's pronounced, f of x equals 8 plus x in parentheses squared. And they'll ask you, what is f of 3? Well, what we're going to do is take 8, add it to, what's our x value? 3, and then square it. Well, 8 plus 3 is 11. What's 11 squared? 121. So you'd say f of 3 is 121. And you're done. Okay? This is kind of a quadratic, which we'll talk about later in the year, these quadratics or squareds. But just plug in the numbers and evaluate. They might give you something like f of x equals 3 times 4 raised to the x power plus 5. And then they'll say, what is f of 2? Well, we're going to have 3 times 4 raised to the 2 power plus 5. Well, that's 3 times 16 plus 5. 3 times 16, I believe, is 54 plus 5. So f of 2 is equal to 59. Not very difficult. Okay. You might also get square roots. They might give you f of x equals 8 times the square root of x minus 53. And they'll say, what is f of f of 72? Well, what you would do is you'd go 8 square root of 72 minus 56, which is equal to 8 times the square root of, well, what's 72 minus 56? I believe it's 16. What's the square root of 16? 4. What's 8 times 4? 32. So f of 72 is 32. By the way, I would recommend if you get into the high 80s and as you go into 90s, you will be given a lot of these expressions with decimal numbers. So have a calculator handy, but they won't be any harder than these other than you're dealing with decimals, multiplying, dividing decimals, adding decimals, which some students struggle with. Have a calculator handy and you should have no problem. If you have any questions, bring them to class and I will help you then.